Start recording now. Right, today we're going to be talking about quadratics. This is a big topic in algebra and in the A-levels in general. It links to a whole bunch of different things, so we're not going to get through all of it in one video. There's going to be a few videos to try to cover this stuff. So we're talking about what is a quadratic. Now this is a special name for a specific type of polynomial. And in this particular case, we have this form here of ax squared plus bx plus c, where a, b, and c are coefficients. They're just numbers in front of the variable x, and this is kind of a descending power of x as we go through. This is the standard way you can write it. These pieces are all just terms, right? So they could be mixed and matched in different orders, but the preferred way to writing it is in descending order, with the powers starting up high and then going down low as you get closer to the equal sign here, which I'm sure we know from GCSE if we've done it through there, but this is part of both GCSE and A-levels. It's in loads of different types of courses as well. So it's the other thing to note is, of course, the form, the shape of the graph that we have here. Now this is a quadratic shape. Okay, we'll go over a few of the basics here. So we've got these two numbers here, so 2 and 7. We can see it dips through the x-axis here. And these are called roots, so this is this bit down here. So x is 2 and x is 7 are roots of the quadratic, okay? Whereas this form here, where you have x minus 2 times x minus 7 are two things which multiply together and therefore are factors, right? And so these words get thrown around a lot, so you need to kind of be up in your jargon, up on the specifics of these words for the stuff. Now this is the general polynomial of a quadratic form here. Notice that the 14 here is going to be the minus 2 times the minus 7. It's going to give you the 14, which is also the y-intercept of this form if this is a very simple polynomial without a factor out in front of the x squared piece here. Because if you put a number out here, that it's not going to hit at 14 anymore, right? But if it's just these two factors, then yeah, 14 is going to be the y-intercept, okay? So that's a quick run over the basics. Okay, so we're going to talk about the discriminant of the quadratic, and this tells us a whole bunch of different things. We use quadratics a lot for other more complicated equations as well, so this is why they stress it so much, because it's a useful tool. Actually, we have a lot of information about quadratics and their forms. So the discriminant piece here in particular does tell us a lot of things about the quadratic as well, and that's this b squared minus 4ac bit underneath the surd sign in the general quadratic equation for solving roots of a quadratic. So we're going to use our one from previously here, and if we put the numbers in from our original one, so a is 1 up here, this is minus 9, and that's 14, so b and c. Pop those into the discriminant part here, and you're going to get 25, which is above 0. And that's really all we kind of care about as far as this part of the discriminant anyways. Okay, and so if it's above 0, we get the discriminant here. Greater than 0 means that we have two distinct real roots. Now that means that distinct means that these two roots are not the same number, and real only makes sense if we do a bit of further maths here. Real is just not imaginary numbers, right? So it's everything else that we deal with. It's pretty much the whole thing that we deal with in A-level maths. If you're on the Cambridge International, though, you do have to go into imaginary numbers as well. So don't really worry about this if you're just in A-level maths, but it just says real roots are here so that they're going to be numbers there. Okay, so if you have b squared minus 4ac greater than 0, that essentially just means that the quadratic is going to hit in two places, right? So it can be either a positive quadratic like this one, or an unhappy one, a negative quadratic, so an unhappy smiley face kind of thing, and this is a smiley face. Helps you remember anyways. Hits in two places, right? So we start going through all the possibilities, and so the next one is going to be if it's just equal to 0, and that's going to be where it hits in only one place. Now this is still one distinct real root. And that would look something like this, where you have the root that it's repeated. So it's going to be x minus a, where this little bit here is a, and it's just all squared. So anytime you have something like this, it's going to sit right on the axis here. It doesn't have to go through the 0, right? Like this one does go through 0, and it would just be like y is equal to minus x squared. So just the repeated root is 0 in this one. So that's kind of a funny one. But otherwise, if this a was like 2 or something like that, you'd have x minus 2 times x minus 2. Right, and so we'd get the same thing repeated, which is why it's also called a repeated root. Where the 2 is repeated, but it still multiplies out, you can see, into a quadratic. And so if you put this into the discriminant with a as 1, b as -4, and c as 4, you should get this part under the surd equal to 0. It means it just touches in one place. So what's the last scenario here? So the last one is where it's actually less than 0. And so if it's less than 0, that means that there's a negative number underneath the surd sign here, just like this, that you end up here. And so we knew about this for a long time, or humans knew about this for a long time, I suppose, not we. But this caused a lot of problems, right? And this is where the invention of imaginary numbers kind of comes from in further maths. But this is essentially, if you get to this situation, it just is telling us that the quadratic doesn't actually intersect the x-axis here at all. And it could be the negative scenario too. The negative quadratic doesn't actually come up to reach the x-axis. So if you get this, it means that this is happening graphically. So this could be something as simple as like x squared plus 4, right? You put it into the quadratic equation, and you get this, where we get 0 as the b here, right? So even though there is no term with the x, you could just write 0x if you don't see it right away. And you plug that in, and you're going to get this nation here. So you get 0 and then 0 squared here. You can see here now that this is going to multiply out to give you -16 underneath the surds. Now there is a way to handle this in further maths, or if you go further with imaginary numbers, but we're not going to do that at A level at the moment, so we'll leave it there. We'll tackle imaginary numbers in another video, okay? All right, to sum up here about the discriminant of a quadratic, it's from a squared, ax squared plus bx plus c from this part here, and it should be b squared minus 4ac. And that is the bit that's going to tell us if it has real roots, which means it's either of these two possibilities, that it has a root that connects to the x-axis like this guy once, or twice like this, that's greater than or equal to 0. And so that's like x has a solution, that x could be equal to a real number or a root where it crosses the x-axis. And if it's less than 0, then it doesn't touch the x-axis. It's the x-axis here, and it just doesn't get there, which means that there is no solution for x, like x is not going to be equal to a number. And that's the reason this is quite useful, because it's a shortcut to see whether we need to try to do any more solving to see if there's an actual answer for that x could be equal to. And this form actually becomes is very useful in the future. That there's lots of things that you'll find out later called hidden quadratics and uses of the quadratic, because this has a lot of maths history around this, and we know a lot about this form. So if we can change things into this form, we can solve for it quite easily. Okay, that's the end of this video, and make sure to check out the next one. It's going to go into completed square and try to show you some stuff from there. So make sure to like this video if you could. Make sure to follow on to the next one.